Have you ever looked at like a tiny, highly technical note and realized it holds the key to a massive philosophical debate? You know, like finding a single shard of pottery
Oh, right,
in
yeah.
an archaeological dig that somehow manages to explain the core values of an entire ancient civilization.
It is a really rare experience. I mean, you go in expecting a dry, mechanical log of facts, and instead you uncover, well, a manifesto. A
Exactly.
manifesto about human behavior, decision-making, and how we balance efficiency with long-term sustainability.
And today's deep dive is exactly that kind of artifact. We are looking at a single blog post. It's an entry dated May 14th, 2026.
Yeah, and the title alone gives us a sense of the journey.
Right. It's called Notes on Haskell Programming, Part 134, Choosing Style Consistency over Conciseness, written by an author named Ang.
Now, I know it sounds like something only a highly special software engineer would care about,
Sure.
but this post strikes at the heart of a universal tension we really all face in our work.
And our mission today is to unpack this dense snippet of programming thought to explore that tension. It is the classic battle between doing something the clever, concise way versus doing it the consistent, readable way.
Right.
Okay, so let's unpack this. I am, very curious about the insights hidden in such a brief piece of writing. I mean, it is barely a few paragraphs long.
Well, brevity is definitely deceptive.
Hmm.
What Ang has written here perfectly encapsulates the daily, almost entirely unseen choices that the architects of our digital systems have to make.
Yeah.
I mean, every line of code is a negotiation. It's between the machine executing the instructions and the human who actually has to read them later.
So it's a balancing act.
Exactly. And this specific journal entry freezes one of those very granular decisions in time so we can examine the mechanics behind it.
Let's start with the action Ang is taking in the post. So the scenario is a minor refactoring task.
Right.
And Ang's first step is applying a foundational rule of programming, which is the DRY principle. DRY.
Right. Don't repeat yourself.
Yes. The text describes pulling a pure function out of individual case branches and placing it at the front of the entire expression.
Well, refactoring is essentially the process of restructuring existing computer code without changing its external behavior.
Like cleaning the pipes.
Yeah, exactly like cleaning the pipes. The program still does the exact same thing, but the internal plumbing is, much smoother.
Right.
And applying that DRY principle is usually the very first tool a programmer reaches for to achieve that smoothness.
To help visualize what Ang is doing here, think of it like going to the grocery store. Imagine you are buying an apple, a loaf of bread, and a carton of milk.
Okay.
If the cash register system violated the DRY principle, it would calculate and print the exact sales tax right next to the apple.
Oh, I see.
And then do the calculation again for the bread and then do it again for the milk.
That sounds incredibly tedious.
Right, exactly. So applying the DRY principle means you pull that repeating action out. You do the tax calculation once, on the subtotal, at the very bottom of your long receipt.
What's fascinating here is that analogy really highlights why the DRY principle is deeply foundational in coding,
How so?
because it goes way beyond aesthetics into actual system integrity. In your grocery store scenario, if the local government changes the tax rate, a non-DRY system forces you to track down and update the tax logic for every single item in the database.
Oh, wow, yeah, that would be a total nightmare.
Right, and if you miss even one, the whole system breaks. By pulling the logic out and isolating it at the bottom of the receipt, you only have to update it in one place.
Which drastically reduces the surface area for human error.
Exactly. You are bringing order to chaos, which has to be a highly satisfying feeling for a developer.
Oh, I'm sure it is. You optimize the system, you clean up the mess, and you make it objectively better.
Which brings us to the real turning point of Ang's post.
Okay.
Because right after applying this universal rule of optimization, right after getting that satisfying hit of efficiency, Ang deliberately stops.
They just hit the brakes.
Yeah, they hit the brakes on optimizing the code any further.
Wait, here's where it gets really interesting for me. Ang explicitly notes in the post that they could improve the code further by removing the manual case matching entirely.
Right.
But then Ang writes, I'm not a fan of that approach.
It is a sudden, very deliberate pivot away from the expected engineering mindset.
Well, I have to push back on Ang's logic here because this seems completely counterintuitive.
How so?
If the entire goal of refactoring is to make code cleaner and more efficient, and Ang admits they could strip out this manual case matching to make the code shorter.
Why wouldn't they just do it?
Right. Doesn't shorter code mean fewer instructions for the computer to process? If we care about software performance, shouldn't we be writing the most mathematically concise code possible rather than, coddling the human reader.
That is definitely the instinctive assumption. We naturally equate brevity with performance, assuming a shorter script just runs faster.
Right, less to read, less to do.
But modern programming doesn't really work quite like that anymore. The code a human types is almost never the exact code the machine runs.
Oh, interesting.
Yeah, a compiler, which is a highly advanced translation program, takes the human's code and optimizes it for the machine before it ever even executes.
Okay, so the computer handles the performance side itself.
Exactly. The compiler is going to make it computationally efficient regardless of whether you wrote it in 2 lines or 20.
So the bottleneck isn't the machine's processing power.
No, the bottleneck is human cognition. Ang provides 2 very specific reasons in the text for rejecting the shorter approach.
Let's hear them.
First, removing the manual case matching hits the readability a bit. And second, it breaks consistency with other parts of the codebase.
Okay, let's break down that first reason. How does making something shorter actually make it harder to read? I would think fewer words on the screen means less reading.
Well, think about the actual lifespan of a software project. Code is written once. It might be edited a handful of times over its life, but it is read hundreds, perhaps thousands of times by different developers over years or even decades.
Oh, yeah, I didn't think of that.
So when you condense a complex operation into a microscopic, highly dense line of code, you save a few seconds of typing today.
But you make it harder for the next person.
Exactly. You exponentially increase the cognitive load on the next person who has to debug that system 6 months from now. They have to mentally unpack all that density just to understand what the program is doing.
It's kind of like reading a heavily abbreviated, jargon-filled text message.
Right.
Like the sender saved a lot of time typing it, but the receiver has to stop, translate the acronyms, decipher the context, and put the whole puzzle together.
That is a perfect way to look at it. You haven't eliminated the effort at all. You've just transferred the burden from the writer to the reader.
And in a professional code base, the reader's time is your most expensive asset.
Absolutely. And that leads directly to Ang's second reason, which is consistency. Ang mentions that other parts of this code base still use these manual case expressions to handle what are called either results.
Okay, let's define an either result really quickly. That means the program has reached a point where the outcome could be one of 2 distinct things.
Basically, yes. In Haskell, the either type is a standardized, highly formal way to handle a fork in the road.
Like a success or a failure.
Yes. Usually it represents a process that can either succeed or fail. Traditionally, the right path of the either type holds the successful data.
Because it is right or correct.
Spot on. And the left path holds the error message if something went wrong.
Okay, that makes sense. So if the entire rest of the software project handles those forks in the road with a very specific, visually explicit structure, suddenly introducing a new hyper-compressed structure creates mental friction.
Exactly. We can actually see this friction in action. Ang gives us the exact code snippets in the text so we can put these 2 approaches head to head.
So what does this all mean for the person actually staring at the screen? Let's open the black box and look at the highly concise approach that Ang is actively avoiding.
The concise version involves importing a library called data.byfunctor.
Okay.
And the code Ang uses as the example of what not to do is a single heavily packed line. It reads, pure time first, unpack, decode, EFAs build to strict result.
Wow. To a non-programmer like me, that just looks like a math equation that got put through a blender.
It is dense. Let's unpack the mechanism there because it is an incredibly clever piece of logic.
Okay, lead the way.
In Haskell, data in this kind of pipeline moves from right to left. So we start with the result, which is our data, and we pass it through 3 distinct functions.
Yeah.
First is bl.toStrict. This changes how the computer holds the data in memory. It moves it from a lazy evaluation where it only reads what it needs to a strict evaluation where the data is fully loaded and concrete.
Okay, so we force the data to be fully concrete in memory. What happens next?
Then it hits decode EF8. This translates raw, unreadable binary bytes into human-readable characters.
Got it.
And finally, it hits unpack, which formats those characters into Haskell's specific string structure so the rest of the program can actually use them.
I mean, that is a lot of heavy lifting for just a few words. But what does the first command do in that line?
That is the byfunctor library at work. Remember our either type.
The one with the left path for errors and the right path for success.
Exactly. A byfunctor is designed to map over 2 possible types. The first command acts like a highly specialized mail sorter.
Oh, so it directs traffic.
Right. It tells the program, apply this strict memory decoding unpacking pipeline only if the data went down the left path.
And if it went down the right
If
path,
just leave it completely alone.
I can see why a programmer would be so tempted by that. It's a completely automated, highly efficient assembly line crammed into a tiny, elegant little box.
It is brilliant, but it completely hides the flow of logic.
Right, because of the cognitive load we talked about earlier.
Exactly. The developer reading it later has to mentally juggle the memory management, the character decoding, the string formatting, and the conditional logic of the bifunctor all at the exact same time.
Now let's contrast that dense assembly line with Eng's preferred, consistent approach using a manual case statement.
Now let's look at that.
Eng writes pure to dollar case result of, and then on the next line, right bytes, and then on the last line, left error, left, decode del.tall strict error.
Notice the visual architecture of that second option.
It is entirely different. It acts as a literal map. I mean, you see the words right and left stacked on top of each other.
Right.
You see exactly what happens if the data goes right, nothing, it just passes the bytes through. And you see exactly what happens if it goes left, it hits the memory strictness and the decoder.
You don't have to mentally juggle a bifunctor at all.
No, you can just glance at the screen and instantly understand the traffic flow.
And Eng validates this readable map-like approach because it aligns with how human beings process information visually.
It makes total sense.
But what makes this blog post truly masterful is that Eng doesn't just settle for clunky code in the name of readability. They find a compromise. Eng introduces a trick to make this consistent approach a bit simpler by switching on something called the overloaded strings extension.
How does that extension change the mechanics of the code we just looked at? Because the unpack command is completely missing from Eng's preferred version.
That is exactly what the extension does. Without getting lost in compiler theory, overloaded strings essentially turns the Haskell compiler into a smart assistant.
Oh, I see.
When this extension is turned on, the compiler looks at the destination of the data, realizes that it needs a specific string format, and automatically handles the unpack conversion behind the scenes.
So it removes the need for the human to manually type out the formatting instructions?
Precisely. Eng gets rid of the unnecessary noise, the clunky unpack command, while fiercely preserving the clear, readable case structure that matches the rest of the project.
They found a way to make the code cleaner without destroying the visual map.
It's brilliant.
It's like restoring a classic vintage car.
Oh, I like that.
You want to keep the beautiful, iconic dashboard and the classic exterior because that is the soul of the vehicle, but you also want it to be reliable.
Right.
So instead of ripping out the entire car and replacing it with a spaceship, you install a modern, quiet, efficient motor under the hood. You improve the underlying mechanics, like using overloaded strings, without violating the fundamental character of the interface.
That perfectly illustrates the balance. You are enhancing the existing structure, respecting its design language, while still utilizing modern tools where they actually make sense.
The idea of design language brings us to the end of the post. We zoom out from the specific Haskell code to Eng's concluding thoughts on why programmers make these choices at all.
Right.
And the sign-off is fascinating. Eng writes, in the end, it's just a matter of taste and preferences, but also whether we want to adopt newer approach or not.
If we connect this to the bigger picture, using the word taste in the context of back-end software engineering is highly revealing.
It really is. I mean, culturally, we are taught to think of computer programming as pure, cold math. We picture binary logic, ones and zeros, objective rights and wrongs.
Right, it's supposed to be entirely objective.
Yet here we have a practitioner deep in the weeds of one of the most rigorously mathematical programming languages in existence talking about their taste. It frames coding as something closer to interior design or architecture.
It absolutely implies a subjective aesthetic choice.
Think about buying a house that was built in the 1920s. It has hardwood floors, crown molding, a specific kind of architectural warmth.
Okay.
You could go out and buy a hyper-modern, minimalist, geometric, stainless steel chair. Objectively, mathematically, that new chair might be better.
Sure.
It might be engineered to be more ergonomic. It might be easier to clean. It might take up less space. But if you drop a cold steel modern chair right into the middle of a warm 1920s living room, it is going to look completely ridiculous.
It clashes.
Yes. It does not match the taste of the environment. Just because a piece of furniture is a newer approach doesn't mean it belongs in an older, established house.
And software engineers face that exact tension every single day.
Right.
Adopting a newer approach like stripping out that manual case matching for a hyperdense bifunctor one-liner, forces a clash of eras within the codebase.
You are dropping the stainless steel chair into the 1920s living room.
Exactly. And the title of this blog post actually gives us a massive clue about the maturity of this specific digital house.
Oh, the title is Notes on Haskell Programming, Part 134.
Right.
This is Part 134.
This is a system with deep roots. I mean, this is not a weekend hackathon project or a quick prototype.
Definitely not.
When you are on Part 134 of a technical journey, you have established a real culture within that system. You have rules, a shared vocabulary, and a distinct aesthetic.
So choosing consistency over conciseness isn't just a technical decision in that context.
No, it is an act of respect. It shows respect for the history of the project, respect for the developers who built the foundation, and respect for anyone, including your future self, who has to navigate it later.
That changes how I view the digital tools we interact with all the time. Every app, every website, every piece of software is the result of thousands of micro decisions about taste.
It's true.
Somebody had to decide whether to prioritize the machine's absolute minimum instruction set or the human being's ability to comprehend the system.
It serves as a necessary reminder that software is written by people, for people. The machine simply executes what we dictate.
Right.
When we prioritize human readability, we ensure the system can survive turnover, scale effectively, and be maintained without driving the maintainers to burnout.
Our exploration of this tiny technical blog post reveals a surprisingly massive lesson. True mastery of a system, whether that is writing complex Haskell programming, organizing your team's shared digital files, or even setting up a workflow for a project at the office, isn't about utilizing the absolute newest, most concise trick available.
Definitely not.
It is not about proving how mathematically clever you can be. True mastery is about readability. It is about consistency.
Yeah.
It is about knowing when to apply your own sense of taste to make the environment sustainable for the humans who actually have to live and work inside it.
The ultimate realization here is that raw efficiency and long-term effectiveness are not always the exact same thing.
Wow.
Sometimes the most effective thing you can do is be a little less efficient.
I love that. And I want you, listening right now, to look at your own workspaces, your own workflows, or your current projects. Where might you be prioritizing cleverness at the expense of consistency?
It's a great question to ask.
Are you creating dense, highly compressed processes that make perfect sense to you today but will completely baffle your colleagues or even baffle you 6 months from now? Where in your work could you benefit from spelling out the map instead of hiding the logic in a black box?
And this does leave us with one lingering, provocative question, building directly on Eng's conclusion.
Wait.
Eng deliberately chose consistency over adopting a newer approach in order to avoid breaking the established style of the existing codebase. But if you always prioritize the old style, and you always reject the newer approach in the name of consistency, at what point does a system ever actually get to evolve?
Oh, that is a fantastic point to end on. That constant tension between honoring the established past and embracing the capabilities of the future. Well, there is always more to learn, and we will be right here to unpack the next artifact with you. Thanks for joining us on this deep dive.